Hello and welcome to the video. This is the first in a very short series showing you how to set up and configure and get the most out of your Sparrow stabiliser. Now these things have been around for a while, and I say a big thank you to a gentleman called Bill who bumped into me at the Western Park show this year and said, could you make some videos on this thing? And I thought, you know what, I have been asked quite a lot over the last year to do this, particularly since things like the ZOHD Copilot Lite was retired a while ago. And this is actually a fantastic option if you're looking for a stabiliser. Now very quickly, before we get too far into this, why would you want something like this over something like full iNav? Well, it's funny, I speak to some pilots who find iNav overwhelming but can cope with setting up something like this. And then I speak to other pilots who think that this is too simplistic and really want iNav. And there's no right or wrong answer, it's whatever you want. So let's talk about that. Why would you want something like this? Well, it performs several different basic functions. The first of all is that it provides stabilisation, just like you would expect. And these are not particularly expensive. I ordered this one from AliExpress. It took about a week to arrive, not particularly expensive. But for kind of less than £30, I got everything I needed inside the box to set it up, including the GPS. But we're going to come on to that in a minute. So as well as stabilisation, you do have that GPS functionality. The GPS functionality, when you plug it in, will give you telemetry back to your radio if you're using something that supports telemetry. I'm going to set mine up with Express LRS here just to show you how that stuff works. It also then means that from a GPS point of view, you also have a return to home function, which means that in the event of a problem or a failsafe where you can just activate it as a mode, this thing will fly the model back to you and circle over your head. It also then, having the GPS allows you to do some other stuff. So you can set up 3 modes on this, one of which is kind of your standard stabilize, and then you can have the middle mode be one of 3 things. It can either be something like altitude hold, where it's using the altitude information from the GPS to maintain the altitude as you fly around. It's quite cute. You can also have what's called fence mode, so you can set the distance away from where you launch to 100 to 400 meters, and when it hits the edge of that virtual wall, it'll kind of fly back to you. Very handy as well. And the last thing is that it will also do the assisted launching stuff. So it means that you can just throw your plane or wing into the air and it'll just take care of everything, which makes launches a lot less risky. The last thing it does, and this is why I've got this one in, this is actually the V3 PRO. And the V3 PRO has a really cute trick up its sleeve. This little port at the back is designed to run HD FPV. So I'm going to connect it up to my walk-snail system here. We'll put walk-snail in the unit, and it's going to provide an on-screen display that you can customize as well, so that I can see things like battery voltage, number of satellites, all that kind of goodness. And I'll probably do the whole FPV thing as a separate video just to keep the runtime under reasonable amounts. So I'm going to put time codes down below to each of the stages. The manual that you can download, I'll put a link to as well. It's pretty good, but hopefully by going through this little video series, this 2 or 3 videos on it, you'll get to the end and you'll be like, okay, I know exactly what I need to do. Let's start with the basic connections. Now, on this thing, as you can probably see, there are a couple of different things. These dip switches here in the middle are used to select things like what kind of model it's going to go into. So a V-tail, a regular plane, a wing, whatever it is. There's also a switch on here to decide whether or not you're going to be talking to a DJI HD system, something like the O4s, or the walk-snail system. So it's great that you have that option. You have a rotating control for gain. So gain setup on this is really easy. If you fly and the plane is twitching, you turn the gain down. If the stabilization is a bit sloppy, you can turn it up. And you also have this other control here, which is more for the second mode that I've talked about already. In the lowest position, it's basically when you flick into that mode, it's manual. It can be altitude hold, and we'll get to that in a minute when we set everything up. And then the pins here at the bottom, we have connections for the model, aileron, elevator, throttle and rudder. The last one can be configured to either also be a throttle, handy if it's a twin aircraft, or it can actually be set up to output a specific radio controlled channel. So if you want to have it to control lights or gear or something else, you can set that up. Then the 3 sets of 4 pins on the right hand side are there for both the GPS, the receiver and a PWM input as well. This supports a massive range of different inputs. Now I'm going to obviously use it with Express LRS, as I've already said. So we're going to plug in the GPS first. The GPS goes at the bottom like that. Observe the polarity, and then the Express LRS receiver is going to plug in above it. Now this will support things like iBus, S-Bus and everything else, but if we connect all the 4 pins as you would expect, then we have done those main 2 connections. That's not too tricky. Next thing I would do then is I would set your dip switches. Your dip switches are going to, again, select whether or not it's going to be a VTAIL, a conventional plane, or something like a wing. I would also then set things like the O1 on the left hand side. That's going to set whether or not it is a DJI style unit or whether it is for walk snail. As you can see here, these are my settings. I have 1 and 2 set for a wing, and I have the on-screen display set to walk snail. So now we have this ready to install into the model. Next thing we need to do is very quickly set up the radio, and I'll show you how to do that and the order of channels and that kind of goodness. So the channel order on the radio needs to look like this. It needs to be aileron, elevator, throttle, rudder, AETR, which is pretty standard at this point in terms of the hobby for things like flight controllers, iNav and stabilizers. That's been the default for a very, very long time. The only thing that I've done here, I have added a little bit of exponential into the aileron and the elevator. We will check the control direction and everything in a minute when we connect everything up to the plane. The other 2 things that I've got, channel 5 has to be a switch to ARM Express LRS. Channel 5 has to be in a high position for the dynamic power and all the goodness to be turned on. So that has to be set. If you're using something like S-Bus, PPM or iBus, you just connect your receiver as shown in this image, and you would put your modes onto channel 5. However, because channel 5 is used here in this instance in Express LRS for good old arming, the modes have to go onto channel 6. The stabilizer, the Sparrow, will figure this out. You don't have to worry about that, but I would just leave it like this for now, and the radio is pretty much set up, obviously by the receiver and everything else is standard. So with this all set, we can go onto the bench and start plugging in a couple of servos and start playing around with things like servo movement, both in the manual mode that hopefully you've just set up, you saw that note, but also to check the stabilization from the stabilizer is correcting in the right direction for both roll and pitch. So installation into the model is pretty easy and straightforward. There's only a couple of things we need to remember really. One is that the arrow here on the case is going to be pointing towards the nose of the aircraft. I'm just going to temporarily fit it on a piece of blue tack that's going to just keep it in place. When I'm happy everything's working, I'm actually going to use double-sided foam tape to position it. And then we need to plug in the 2 control surfaces on each side, and you just use this diagram that's in the manual, which is pretty straightforward. Now as this is a wing, this gets super simple, because all we do is we plug the left hand side into aileron, the right hand side into elevator, observing polarity. Now I'm not going to plug in the ESC at this moment. The reason being is that I like, when I'm doing these kind of things, put these pieces out either side, to power it from something like a 5-volt BEC. So it's the 5 volts from the ESC that's going to power the Sparrow, the receiver and everything else. So I'm just going to plug that into one of the spare PWM outputs, or let me just pop it in. Again, just be careful of polarity. The negative pin is towards the outside of the case, and I'm actually going to power it from that, and that way then we're going to be set. So radio is on, props are not on. I know I haven't connected the ESC. This should be pretty safe, so let me just power it. We're going to see it. Good news, we have a couple of cool things happening here. First is the receiver is green and powered. The next is the GPS is lit as well, so that's good. We have flashing lights on the Sparrow, and the lights, what they do is all in the manual, but we have a flashing red LED. Hopefully you can see that on the camera. And then we also have a flashing green LED, which is indicating that we haven't got a GPS lock, and at the moment we're in stabilise. Now, the way I would recommend we do this is, let's just show you how this works. Let me just put this into manual mode. We're now in manual, and as I move the controls, we can see that aileron is backwards, elevator looks okay. So in manual mode, what we'll do, we'll go into the model menu in here, and we'll page across, and what we'll do is we will change in the mixer the aileron polarity. That's the easiest way to do it for this. So I'm just going to go and say edit, going to go down, change that to a negative number from the positive one. However, I'm not going to go all the way. That's quite a lot of movement on the roll. I'm going to go up to about -80 and hit enter. If we come all the way out of that, we see now that the aileron is moving in the right direction, and I'm happy with the amount of movement. The elevator is moving a little bit high as well. Now, normally the way I'd recommend you do it if you're playing with this is do have a go at trying to get the control linkages into the neutral position as close as you possibly can, and also change the linkages so that the throws are right. Don't try too much fixing here. If they're too much, unfortunately I kind of maxed out the configurability of the linkages on this particular wing, so I'm kind of stuck having to very quickly just go into mixes. I'm going to do the same, so I'm just going to drop down to about 80 as well, and then calms down a bit too. Everything's moving in the right direction. Now we have got a GPS lock. The red LED, hopefully you can see that on the camera, on the Sparrow has gone solid. That means we've got a lock. Next thing we need to do then, you'll notice at the moment there's no movement from the controls. That's because we are in manual mode. Let me pop it into a self-level mode. And now if I tilt the nose down, you'll see that the control surfaces are pointing down. They're trying to correct in the wrong way, which probably means if I roll it, it's the same way. So both, in my case, both elevator and aileron are correcting the wrong direction. So what I need to do is go and just move the dip switches for A and D into their opposite position, and just confirm that that corrective action is moving in the right way. If you're struggling to see that corrective action on your particular model, you can turn up the gain. I've got my gain set for about 50% here, and I'm going to probably fly it on that initially. Last thing to show you, which is very cool, because this is CRSF, and this is quite a clever little thing, it has started sending telemetry back. So if I go into the model menu and I go into telemetry and we discover new sensors, you will see that we have absolutely loads and loads of things in here, including the number of satellites, horizontal speed, loads and loads of fantastic stuff. And so this is actually really cool, the way that you get all this information. So let me just power it off, reverse the corrective direction for both pitch and roll, and then we can do things like level and the final last bits of setup. So the last two things I do before I finally fit everything and then take this for a fly is to calibrate the radio and then to calibrate level. So let's do the radio first. That's the easier of the two. So what we need to do is we need to power everything so that we are connected and that everything has initialized. Once everything is connected, then what we need to do with all the trims in the middle position, we're going to flick the flight mode a number of times. However, what I would recommend here is that if you know what the control surfaces need to be in, maybe you've flown it and it's been really good and you know where it needs to be, so maybe there needs to be a little bit of up elevator, maybe there needs to be a little bit of bias one way or the other for whichever control needs to be in whatever position. I would just get them, particularly if you're in manual mode, I would get it so that each of the control surfaces are where you need them to be. I'm just going to reset all mine because I don't know yet, but normally I would have them slightly up at the back. But when you have everything set, if you don't know how you need to do it, just get everything neutral, do the servos so that everything lines up. We're going to flick the flight control a number of times, and the control surfaces are going to move to let it know that it's copied that. That little dance it did means it saved the radio control stuff. So that's going to be the default position. I would recommend that what you do is after your first flight, if you need to trim it in manual mode, come back and redo that calibration so that it knows how everything's going to work. The final job in the basic setup then is to calibrate what level should be. I would recommend putting the wing or the plane on a level surface and putting the nose up slightly. Most wings and planes that I play with here need a little bit of nose up. So I've just stuck something under the nose to make sure that it's going to try and fly in that attitude. We can change it later on if we fly it and we find that it's always gaining altitude. We can have that on a slightly more downward angle, but we'll just guess it for now. Now to do this, we need both of the channels to be at 100%, so get rid of any adjustment that you've got. So, and this is something that catches a lot of people out. They reduce the travel to make it all work in the way they want it, then it won't notice how things are working. And to do this is quite simple and easy. What you have to do is keep your eyes on the two LEDs that are part of the stabilizer, and we need to put the sticks to the lower outer position, and we need to hold it there until the lights start to blink together. They're about both blinking together. When they are, we need to put the sticks in the middle position, again keeping everything very still, and then the blinking will stop. It'll go back to the default position, and we've now trimmed it for that slightly nose up attitude. Again, you may have to tweak that once you've been flying. Last thing for me to do then is to put the movement back down to where it was. If you remember, I kind of reduced the movement, so I would do that. Again, you just have to remember to put those back when you're playing with things like the calibration level. Lots of things are done on the sticks with stuff like this, so you have to be very careful that you're not trying to calibrate, because it will see the end of travel for the sticks as you entering that particular mode. So here is what it looks like all installed in the wing. So I've installed it into the position we had it before with the double-sided pad that comes as part of the kit. I've popped the GPS here at the back, so that's got a clear view of the sky. I've stuck the antenna in vertically here at the side of the wing. That is the best way, in my humble opinion, to do it on something like this. So with that all done, then there's a couple of cute little things I can show you. So if I just power this up, the things like the throttle, there we go, won't work until you have a GPS lock, unless you're in manual mode. So be careful of that. Obviously check that it all works. So at the moment, if I activate the flight controller by going full throttle and low throttle, still won't get anything. However, if I go into manual mode, the ESC will finish, and then I can run the motor. However, I would probably go through and do a simple motor calibration. There's a little bit of dead band here at the bottom where it's not doing anything. Pretty standard stuff. So you have to wait for the GPS to lock in order for it to activate. And I'll probably do a video showing you the flight steps with this as a separate thing. Couple of other little top tips. By default, it's going to use channel 12 as the RSSI value. Check the documentation. You can set up channel 12 on the radio. That's what the Sparrow will use to show things like the signal strength in the on-screen display. I potentially would use flight modes on the radio so that I could trim it for manual and then land it. That little noise there means that it has a GPS lock, which now means the throttle is going to work. And that's because it's a safety thing. Again, I need to just calibrate my ESC, and I'll do that after this. You can use auto launch to fly it. That's just put it into return to home, put it at an appropriate throttle level for it to fly, and then chuck it. I'll show you that too in another video. But I would fly it in manual mode and trim it up, and then come back and then recalibrate the radio control with those new trims. The way that I tend to do it is use a flight mode to store those trims when the flight mode switch is in the manual position. If you're interested in that, put a thing down below. Check out my HTX for Beginners series. I explain what flight modes are. One of the cool things is you can save different trims, and I would use them for something like this. If you're never going to fly in manual mode and you're always going to be flying in stabilise, then you know what, you can completely ignore all that stuff. So next time we'll complete this up. We'll go and put the on-screen display in here, and I'll maybe do a couple of kind of what you do at the field to get it to fly. But as you see, there is no computers. We haven't had to plug in a USB anything to get this to work, and now we have a stabiliser that's ready to go at the field for a test flight. Thank you for watching my video. Check out the playlist, and adding Painless 360 to your search terms will help you find my content. If you haven't done so already, please hit the like and subscribe button. It helps a lot. You can support the time I spend here answering questions and helping others by using the links in the video description.